Hi, this is Roger from Kanka Labs, and today it's about measuring SMD components. I'll show you some tools and devices that are helpful, especially when measuring SMD components in circuit. Now, what I do 90% of the time, I use my normal multimeter and don't use the test leads that are supplied with it, but I always work with these test probes with ultra sharp tips. I've demonstrated them to you in another video. You can see they're quite heavily used. One has even the tip is even bent a little bit, but it's still very, very sharp. And the advantage is not only that you can use your normal multimeter, because they are so sharp, you don't have to care about the shape of your components. They easily hold just by the force of the sharp tip. And so probing with these ultra sharp probe tips is one of the best ways just to measure components. But let's see how far we get in a real circuit. This is our little AM modulator. You already could see if we measure resistors, we got here. And the nice thing is here that the values are on the silk screen, so we can directly compare. We have 220 ohm, yes, that's okay. We have another 220 ohm, and you see it's okay. What else do we have? We have three 1 kilo ohm resistors. They should all measure relatively equal. 1K, there's the next one, 1K, and 1K. So no problem with that. Next is our capacitors. Let's go over to this 100 nanofarad one. And so the multimeter has a problem and gives us 58 microfarad. So that's clearly wrong. So here we have the first problem. Let's probe another 100 nanofarad one. Yeah, this gives us 200 nanofarad, so there's also a little problem. But this could be that these two are in fact, over some resistors, are in parallel. So it could in fact be true, but you see we don't get exactly what we expect. And next is the two 22 picofarad capacitors, which go on the one side to ground and on the other side to the quartz crystal, you can see there. We have to null out, of course, before the measurement. And we should get a 2 at the end. Yeah, okay, we get something between 20 and 40. It's a little bit rising. In fact, we would have to measure 44 picofarad because they are also, by the way of the quartz crystal here, more or less in parallel. So that was quite okay, but you could see here this 100 nanofarad one, it gave a totally wrong value of 58 microfarad. So obviously this is not the perfect way or the best way to measure components in circuit, but anyway, you don't have to buy an extra multimeter. I find it much more ergonomic just to use your normal multimeter with these ultra sharp probe tips. Now, you can find on eBay some of these adapters which plug in your multimeter and have this little tweezer type tips, but they are really bad. The tips are not sharp. If you want to measure on a components where the leads are far away, that doesn't work. And if you measure very small components, I've bought this once for, I don't know, 2 or 3 euros. That's quite cheap on eBay. But in the end, they are useless, and much better is to use just these ultra sharp probe tips. So, but what you also can find are these extra tweezer type, like, well, not multimeters, but they are more like, the usual function is you can measure resistors, diodes, continuity, and sometimes also voltage. So they have a limited range of applications. But let me first of all show you one other limitation, and that is if we go into diode mode. Here the X-Tech multimeter has a no load voltage in diode test of, I think, 3.7 volts. And you can see, although here the blue LED is lighting up, we don't get any display. So here we have, just by chance and by good luck, we could see that this LED is okay simply by seeing the blue light. And the same is with the white one. It just lights up, but we don't get any display. And these tweezer type testers, these SMD testers, because they work on a coin cell with 3 volt, while here we have 9 volt battery, they have a test voltage for diodes of only 2.7 volts. So not only won't you get any display with them, with 2.7 volts maximum test voltage, usually your blue or white LEDs won't light up. So they are not useful for testing LEDs. And there's another problem. If you have any component in parallel to a PN junction, which could be a diode or a bipolar transistor, then you also will most often get wrong or misleading results, simply because in diode and resistance test mode the PN junction could turn on and give you a completely false or wrong or misleading results. So I don't know if it's really such a good idea to buy such a tweezer type simple SMD tester. The one you will find if you put in SMD tester or SMD tweezers at eBay, you will find the predecessor of this one, and it is the MASTECH 8910, and there is also an A version, MS8910A, and that has a diode test voltage of 4 volts. And 4 volts would of course be completely sufficient for testing 99% of all blue and white LEDs. But this A version, the MS8910A, seems to be sold out all over the world. I've Googled them and took the first 50 results, and all the suppliers at eBay and directly in China, they all have this A version sold out. So sorryly, the MS8910 is not so recommendable and the A version is sold out. Hopefully they will produce a new one. But you could see this one is the MS8911, and this is a totally different beast. It's in fact an RLC meter, and we'll come back to this one just in a minute, because most multimeters can at best test resistors, capacitors and diodes, and of course voltage. But concerning components, what do you do if you either have an inductor that you want to test, which no normal multimeter has a function for? Well, then you could get the idea, let's take our cheap component tester, which I also extensively demonstrated here in several videos. It can test all types of components, but you have again 2 limitations. With these little mini grabber test hooks, it's not so easy to probe SMD circuits. Of course, you could make your own adapter and put some test leads there are also smaller versions of these probe tips available in different forms and shapes. So that would be one way, but these testers have a relatively high test voltage of usually 5 volts, and you will also get misleading results when trying to test components in circuit. So they are basically not useful for, although they can identify all kinds of semiconductors, resistors, diode, inductors, capacitors, nearly everything you have on your circuit except for ICs, of course. Due to the high test voltage, they will usually give you wrong results. And what you don't want to do is desolder your component, test it, and resolder it. So what's the remedy? We could, of course, take a real LCR meter. So my trusted MASTECH MS5308, which is the ugliest LCR meter you can get on the market, but it's the cheapest one that can measure up to 100 kilohertz test frequency. You can set it from 100 hertz in steps of 10 up to 100 kilohertz. And it has the nice feature that the test adapter not only has this Kelvin clips here for through-hole components, but you also get supplied this adapter with really sharp SMD-Tweezers as test probes. So that would be already quite nice to have this one. It's basically the same technique as using your multimeter with the ultra-sharp probe tips. Here you have these sharp tweezers, which is okay for measuring. But here again, the test voltage is simply too high because PN junctions will turn on when trying to test these. And many years ago, you perhaps did hear of what are the real SMD tweezers. It's a trademark named from a Canadian company who have developed a measurement device that is still smaller and is very sophisticated, but also costs top dollars. This thing has evolved over the years, and you can buy different versions now between $200 and $400 or euros, and that's clearly too much for most of the hobbyists. Now, and just last weekend I saw an ad by Elektor-magazine promoting this new MASTECH MS8911 smart SMD tester, and in fact it's a real LCR meter. And now let's go into some details why I immediately ordered one, and it took 2 days and arrived, and except for some minor problems that I will complain later about, this thing is really beautiful and useful, and it costs 1/10 of the original SMD tweezers. It's between 30 and 40 euros, and so the right price range for us hobbyists. So let's take a closer look at this thing. So that's how it arrives here. You have a protective cover here, and to protect just the probe tips, and you get a pair of extra probe tips, spare probe tips. And that's the first thing I am complaining about. Well, at first it might seem a good idea to have here these slotted tips, but in my view this is not such a good idea. The idea behind it probably was that you could probe also through-hole components with leads, and that you could put the tester here firmly so that the slot gets over the leads of your component, but therefore the range of the distance here, which you can only close, you cannot open it any wider, is clearly not sufficient, because you would have at least expect, let's say, 10 millimeter as the widest opening. And so most of the through-hole components with wires, they simply just don't fit. So if they would have made the opening of the jaws or the distance here between the tips a little bit wider, that would perhaps be more practical. But anyway, if they already supply a pair of spare tips, why don't they make one of them really sharp, just like this one here from the same company, the adapter for the big LCR meter, and that's how you expect them to be, with sharp probe tips. And let's compare. The opening is already wider, the maximum opening, and so I probably will either file down these ones or just buy some spare parts for this one and exchange them, because they seem to have the same distance of the screws. So it shouldn't be difficult to get spare sharp probe tips that you can replace here. So that idea here to have slotted tips, in my view, is not the best idea. But now come the good parts. Let's turn this thing on, and you can already detect some things that you don't find very often. So we get, first of all, a dual display, because as an LCR meter, it measures also, depending on what kind of component you're testing, the dissipation factor or the quality factor. And you already can see here we have standard a 0.5 volts RMS test voltage, of course an AC sine wave as a test signal, but you can change this to 0.1 volts, and by pushing this button a little longer, and now you can see we have 0.1 volt RMS, and that is clearly for just not turning on any PN junction, so that your measurement result is not affected by any PN junctions in parallel. So very nice idea. And then you can see the second designation here on the push button on the key. You can switch the hertz, the measurement frequency, from, at standard, when you switch it on, it's 100 hertz. You go to 120, 1 kilohertz, and even 10 kilohertz. And that's a very nice feature that you can measure with test frequencies up to 10 kilohertz. Of course, 100 kilohertz, which the smart tweezers, the expensive ones from Canada, can do. That would have been a little bit too much to ask for 30 or 40 euros. But anyway, the combination of 0.1 volts RMS test voltage and going up to 10 kilohertz is really a nice feature. And you can, when you switch it on, it is in automatic mode, so it will try to automatically identify the component, if it's an inductor, a resistor, or a capacitor. And of course you can also cycle through manually. At the moment we are at L, so inductor measurement. And now we're measuring ohms. Next is the pure DC resistance, probably with a DC voltage measured. And again, back to inductance measurement. So that is really nice. You have another hold button and an on or off switch, and it also has auto power off. It's all operated by a small coin cell, I don't know, a CR, what is it, 2450. And MASTECH is a test and measurement company in the low-end range, but with a very good bang for buck ratio. And you can recognize them by their green color. And they have nothing to do with X-Tech, which also have green multimeters. So anyway, if you Google MASTECH, well, you will find that it looks like their headquarters is in the US. But I found some other sources about MASTECH Taiwan, and I think that they are really settled not in the US as a manufacturer. They're clearly manufactured in Taiwan, and nevertheless, I'm quite happy with MASTECH instruments. You could see here my big LCR meter, although ugly, has a very good bang for buck ratio. And so let's do some testing of our AM modulator if we get some better results at the problematic components than with our normal multimeter. So now comes the hard part for me, because on the one side I probably can't get both the PCB and the display in focus. Second is I'm a left-handed person, and because this is not a dot matrix LCD but a graphic LCD, of course I cannot hold it the way that I usually would hold it. Then you couldn't read the display anymore. and working with my right hand is not so easy for me. And third is getting both the component, now we had the auto power off, both the component and this thing somehow held the right way is really hard for me. But here you can already see we have here 0603 size of the SMD components, and I can here the slotted tips are there simply too big and not very good. So one thing you should also know about is the measurement range. What is the minimum and maximum component value that you can measure depends on your set measurement frequency. And usually you can measure the lower values of inductors and capacitors with the higher frequency. So the best compromise is probably to set it always to 10 kilohertz, as I did now, because usually you want to measure the smaller ones. And let's try the 22 picofarad, which should measure in fact as something around 44 picofarad. Yeah, and we get 38.6 and a dissipation factor of 0.003. Why do we get nearly the double value? Because, as I explained already, in fact these two capacitors here are more or less in parallel via the quartz crystal that is in between them, which acts here like a short, and so that was quite okay. Let's try the 220 ohms resistor, which should be no problem to measure. Yeah, 220. By the way, the given accuracy is, depending on the measurement range, is around 2%. So it's not about precision measurement, but to identify the component itself and give a more or less good, well, not guess, but a sufficient measurement accuracy. Now let's take the 100 nanofarad and let's see what we get. That gives us 94.3 nanofarad. Okay. What else did we have? Where was the problematic one? Was it this one? Let's see if we get any better here. And here we also get 97.4 nanofarad. So you can see this one here measures both the 100 nanofarads correctly, while with our multimeter we had at one of them, I think it was this one, the problem that we got a totally wrong display. So there you can already see that it's better to have 0.1 volts measurement voltage. Let's try the 100 picofarad one. Just have to grip it the right way. 147.48, correct. And the 3 1 kilo ohm resistors. And you can see not only that it's complicated for me here in front of the camera, but really the slotted tips, I really start to hate them. Because you don't know now, doesn't it have any contact or is the component wrong? And here we get a wrong value of 180 nanofarad. That could be that the 180 or two of the 100 nanofarads are in fact in parallel. So this could be right, because we get only we get a dissipation factor of 6, so that I would have to look into the circuit diagram. But this could be correct. Let's take the other two should measure correctly. Yeah, 0.996 kilo ohms, so 1 kilo ohm is correct. And now I get the problem. I'll try it this way, so that you can see the display. And of course I have the reflections here from the photo lights. Oops. Yeah, you can see you always get off with this too big tips, so that's the only thing I can really complain about. That you have to exchange them for really point-like tips and not this fork-like tips. Yes, So another thing that I just recognized was when it goes into auto power off, it forgets the last setting of frequency and measurement voltage, and it would have been nice that it could store the last set frequency and voltage, because most often you will have this combination, 0.1 volts RMS measurement voltage and 10 kilohertz measurement frequency. Now let me just take a minute and I'll exchange these really tips to throw away and see if this one here fit and if I can have a better usability with these tips. So that was an easy 1-minute fix, exchanging the tips here. Let's see what we get with the 3 remaining 1 kilo ohm resistors in a way that you can also read the display. Sorry for all this video setup, but I can't do it any better here, and it's probably a pain in the ass to watch this video. Oh, what do we get here? 180. I think we had this, that in parallel to this resistor are probably 1 or 2 capacitors. Yep. What does the next one give us? Yeah, this gives us the correct 1 kilo ohm. And the last one probably also doesn't give. Anyway, I can grip the component much better now. Yeah, we again get 180 nanofarad, but this is not the problem of the test device here of the MASTECH. It's simply because there are capacitors in parallel to the. Let's see if we can manually go change to resistance mode and just go to DC resistance. If we now get for all 3 of them the correct value. So the first one gives 1 kilo ohm. The second one gives 1 kilo ohm. And the third one gives 1 kilo ohm. So that's the trick for resistors. It's better to go manual to DC resistance, just to avoid that in fact you measure components that are in parallel to the resistor and then you get the right value. And only for capacitors and inductors you go either manual if you know which component it is, or into the auto. So basically I'm quite happy with this thing, especially concerning the price. The outstanding features are not only that it's a full-featured LCR meter with a dual display, but also with changeable measurement frequency and going to 0.1 volts RMS test voltage. For that price, that's really outstanding. What I'm not happy with is are 2 things. You have to exchange the tips. That was pure luck that I had the one that exactly fit here from my other LCR meter, and that the settings are forgotten when the auto power off starts to come in, because you always have to reset it to 0.1 volts and 10 kilohertz, which is usually what you measure with as settings. So that was it for today. I think the combination of your standard multimeter with the normal test leads and the ultra-sharp probe tips on the one side, or the MS8911A for measuring standard components like diodes or voltage measurement, in combination with this one, you get for really low money, you get really what you need to measure SMD components in circuit. But nevertheless, you have to take care of some of the settings, measure resistances if you know that it's a resistance, and probably resistors are the only passive components that you can directly identify, because they usually have their value printed on them, while inductors and capacitors, I've never seen one with a marking. So you know when you measure, usually know when you measure a resistor, just better go to resistance, DC resistance mode. And for the other components, take the auto setting. So all in all, I would recommend this thing. I'm quite happy to have it and to quickly have gotten one. So I think this is a good addition for not only the hobbyists, but also the semi-professional lab. And so thanks for watching, and pardon me again for the jerking of the video, and it's not so easy for me here when it comes to shooting here such small fields. The camera is not really suited for that. So anyway, thanks for watching. Until next time, bye from Roger, bye from Kanka Labs.